The silent properties of these materials: 1. Can withstand high temperatures without melting or decomposing. 2. Remaining reactive and inert when exposed to severe environments. 3. Can provide thermal insulation. Application: furnace lining for metal refining, glass manufacturing, power generator. Refractories has 4: fire clay, silica, basic and special. Fire clay, alumina plus silica, can be used up to 1500 degrees Celsius. Application: in furnace construction. First, to confine hot atoms. 2. To thermally insulate structural members from excessive temperatures. Second, silica. Contains silica, can be used up to 1650 degrees Celsius. Application: used in the arched roof of steel and glass making furnaces. Third, basic. Magnesium oxide plus carbon, chromium and ferrum. Application: used in some steel making open heart furnaces. Special: relatively high purity oxide materials. Example: alumina, silica, magnesia, zirconia, silicon carbide. More expensive. Abrasive: used to wear, grind or cut away other material, which necessarily is softer. Properties: first, high hardness. Second, high wear resistance. Third, high degree of toughness. 4. High thermal resistance. Example: diamond, silicon carbide, tungsten carbide and silica sand. They have two forms of abrasive. First one is coated abrasive. Example is sandpaper. Second one is loose abrasive. Example: diamond, corundum and silicon carbide.
Okay, so now for the cements. So the cements, when it mixed with water, they form a paste that subsequently sets and hardens. For example, like cement, plaster of Paris and lime. So the mixing or bonding also can be done at room temperature. In the process by which element hardens, it is not actually drying, but it's rather of hydration, in which water actually participates in a chemical bonding reaction. As for now is advanced ceramics. So advanced ceramics, the development of new materials. It is used to increase or enhance the properties of traditional ceramics for electrical, magnetic, optical and mechanical properties. Advanced ceramics is utilized in optical fiber communication systems and micro electromechanical systems. So for advanced ceramics, we have 4 different advanced ceramics. So the first one is piezoelectric, which is used for barium titanate, lead titanate. Second is micro electromechanical system that use silicon carbon nitride and silicon. Next, for the optical fibers, it use high purity silica that is free from contaminations and defects. And the last one is ceramic ball bearings, which use silicon nitride and silicon carbide. So now we move to the fabrication and processing of advanced ceramics. There are 4 simple steps when we want to make the advanced ceramics. So the first step is batching and preparation of powders. Second step, forming. Third step, drying. And the last step is firing. When the firing step, there are sintering process occurred. So basically, there are 5 different conditions when it comes to advanced ceramics. So for the first one, for slip casting, we use raw materials like slurry. And for tape castings, we use raw materials that also slurry, specifically to aqueous slurry. And for the extrusion, we use raw materials like plastic mass. And for injection molding, we also use raw materials for like plastic mass. And for the last one, and dry pressing, we use for materials like ceramic powder.
Okay, now I want to talk about slip casting and extrusion. Slip casting is divided into two main variations, namely solid casting and drain casting. What is drain casting? Drain casting inverted mode to drain excess slip after a semi-solid layer is formed, resulting in a hollow product. First, insert the pour into the Paris mold cavity. Second, water is absorbed into the plaster mold to form a firm layer. Next, the slip is poured, then the green body is removed from the mold. So how about the solid casting? Solid casting is to produce solid products. Adequate time is allowed to entire body become firm. First step, solid is poured into plaster of Paris mold cavity. Next, water is absorbed into the plaster mold and the green case built. Next, I want to talk about extrusion. Schematic diagram shows the machine used in extrusion process for ceramics, how it works. Extrusion reinforces the ceramic paste through a die, resulting in a long products like rod, bars, long plates, and pipes of regular cross-section, which may be cut into pieces of required length. So the extrusion is used for manufacturing furnace tubes, thermocouple components, and also heat exchanger tubes.
Today I want to talk about dry pressing, schematic representation of the step in uniaxial powder pressings. First, die cavity is filled with powder. Second, the applied powder is compacted by means of pressure applied to the top die. And then the compacted paste is ejected by raising action of the bottom punch. And last, the fill pushes away the compacted paste, and the fill step is repeated. Okay, summary for types of forming process regarding raw ceramic materials, component size, component shape, and production volume. First, I want to talk about forming process for slip casting. For slip casting, the raw ceramic materials form is slurry and for component size is large. And then component shape for slip casting is complex and production volume is low. Okay. Second, forming process tape casting for raw ceramic materials form is slurry, component size is thin sheet, and component shape is simple, and last production volume is high. Forming process for extrusion, raw ceramic materials form for extrusion is plastic mass and component size is wide range. Component shape is constant cross section. Production volume is high. Okay. Forming process for injection molding. The raw ceramic materials form is plastic mass, component size is small, and then component shape is complex and production volume is high. Lastly, forming process for dry pressing. The raw ceramic materials form is powder, component size small to medium, component shape is simple and low aspect ratio, production volume is high. Thank you.